What are we going to talk about today is about test theory. What is a test theory? It's a theory regarding to how you should, what should be the basic idea of generating the test. And what should be the guideline, the proper guideline of how we should test the software. Okay. How should we, what should the guideline how we should design and the theoretical guideline how we can design the test. Just like what I described on Monday, testing is what should we do? The simple process that can be explained just like we select the data from the infinite test set of data. So what kind of data should we select that proper to our test? What should be? How can we know? How can we select the proper data for test? It depends on what? So how can we select the data for test? What kind of data should we select? From last time, if you watch the video, just like I already discussed about this. From this example, I already discussed what kind of data that we should be used for test this website, right? And the guideline is that the basic scenario, the basic theory is that we should perform dynamic verification of the behavior of a program on a finite set of a test case, which is suitably selected from usually infinite execution domain against the expected behavior. What does this mean for infinite execution domain? It means that normally if we talk about software, if we deliver our software to the customer, the customer will use it. Such as, for example, if you develop the games and handle to the game online, and 10,000 user playing your game, how many execution happen in your game is more than 100,000, more than a million. That is why we should try to select the data, the proper data, which is if we execute for many times, repeatedly or unrepeatedly, unexpectedly over time. And that is the thing that if That is the thing that when we deliver the software, but before that, if we need to test the software, how should we select that kind of software, that kind of test? How should we design the data? That is the point is, normally there are three types of technique that we use in software testing. The first one is experience-based technique, just like you know what the software is going to do. You can expect the output, and then you can design the input. But before you can be experienced tester, you need a lot of learning curve. And then we have the other and the main two technique that which is our way talking about and our way explain is like the first one is black box testing, second one is the white box testing. And theoretical we can say that the black box testing is like specification based. What is the meaning of specification based? It's like we test the black box testing. It will be high level. We are going to test just like test the user requirement specification, whether the software is working corresponding to the user requirement specification or not. And we don't care what is inside. We don't care how many methods is run. But if we have some kind of, for example, user story, start the process until end, and we follow the user story, we follow user requirement specification until the end, and we get what is this kind, what is expected by the document, and if we get that from our test, it means that it's okay. We don't care the kind, the detail of the data in the. We don't care how the data is called. We don't care about the detailed things because we just care that okay. If it's work as we want, we don't care what is inside. That is an idea of the black box testing. And then for the white box testing, it's a code based. What does this mean? Actually, they said it's a white box, but when we have a white box, we still don't know what is inside. But you know, some for my explanation is like clear box. What does it mean? It means that the box that we can look inside, we can touch, we can go into as many detail as we want into the basic functional unit. And we need to test this whether each unit is working as we want and compose it into one box. So this is a two main idea of software testing, black box testing, white box testing. But yes, some people may say that we have experience-based software testing technique. Yes, that's it fine. But this is not well explained. It cannot be well explained. Whether how can you judge the experience of the tester on how long they have been working, on how they are success testing their or whatever it is. But just by term, what else? Just complete. What else? It is definition of experience. Yes, I don't know. If you don't know, so it's just if you need to test software, sometimes you are able to find the experience tester, and you are able to identify whether they are good tester or not. That's just okay. But if not, if you need to start working on the software testing, the two starting point is that you need to define the black box testing and the white box testing. And correspond to the black box testing, it should be on specification, usually in a high level base. We don't care what is inside. What is the detail mechanism, detail method called detail sequence in the box. We don't care. We just like, okay, if we get this box and if we call this and it's work, that is fine. Corresponding to the specification. But and if the white box is passed, it's okay. And normally in a small software house, in small teams, so sometimes we just do the black box testing. And yes, it's okay for 80 or 90% confident that this is working. But by that, it still have some unexpected behavior of the software. Also, the white box testing is that the idea is that code based, and we are going to every single method. The system. And okay, we will come back to the detail of this later. Yes, this slide will explain what is the experience-based technique. We have testing only for some special purpose. We use some kind of exploratory testing. That's a test execute at the same time and rely only tester knowledge and experience. That is it. Then we call it design, execute, and modify. Just like maybe some just one people testing on whatever they prefer software. But the black box testing is like we test from specification, we have the user input. We don't care how to implement, how the program, the system is implemented. We care about, okay, if we get the expected output from the input, that is okay. So getting back to the question of what should be the proper test input that we should design in order that we can get the proper output, which is corresponding to corresponding to this sentence, this motto. This is I test the testing idea. We should provide as ideally we should provide every possible input into this box, and this box should give out the output that we expected. And then the question is, do we have a time to do we have enough time? Do we have proper amount of time? If not, what can we do? What can we do? What should we do? Can someone just give me the answer in the chat box? Yes, this is the black box testing. We need to provide input to the test, to the system, and we just get the output that we expected. But what should be the way of selecting our input? What should be the theoretical part that support? Okay, if we have this kind of input, if it's enough, how can we decide that it is enough or not for this kind of input testing that will give out all the possible output that we expect? You have any idea? No idea. Okay, that's fine. The thing is, from this, you may have no idea of what is this, but okay, just how about this program? What should be the proper input? Because if we, how many input we need to take? We have to input the currency type, we have to set it or input it, and we have to input some number, and we click calculate, and the output will be like this. So how many input we have for one execution? At the least, the smallest number of input is just like we input this one, and we click calculate, then we get this output, right? So how many input we need to use for this test? This until this, which one we should use? Should we start from 1 or 0 like this? See that there are some unexpected behavior here. See that there are something happen. Even the input is translated to something. So if you have to design the input for this, design the input for test, where should we start? In theoretical, there are the things that the wording, the idea is that we need to find the equivalent class testing. The idea of equivalent class is that a set of partition program which respond in the same way. Okay, which is we can reduce the redundancy in our test. And to ensure that if we decide the proper amount of input following the equivalent class testing, we can be quite sure that our test is complete. So how we decide that, how we get this kind of equivalent class? Just we can start by looking at the input that treat the same or the same part of the output. What does this mean? It means that if we input 1 here, calculate, that is equal to input this and calculate. Is it equal? This is almost the same. 10, 20. It's provide the same part of the calculation process, and we can expect that we input the THP and we can expect the output as this one. It should be exact result. And if we change this type and we calculate, so how many equivalent class that we should use for testing this in this example? How many? Can you guess? You can thinking about, okay, if it's a numeric integer, just like 1 until just like 65,000, this is the same data type, yes, and from this program, it should provide, we put the integer input and we will get some kind of the double or fourth output. It's okay. How about, this is one thing, if we input some kind of double occurrency value, we will get out to this kind of number. So this is okay. If we think about input the number, if we input the number, we will get a number out. This is first example. If we input the text, what should we get? We get, this one is you return as it's an NaN, it's a nothings. So, and the result here is nothing. So if we can design that, okay, if you want to test this website example, if we input the number, we should get the number. And if we input something else, it should not display anything. And the input value should be converted into the NaN and show here. That is two tests, two idea of equivalent class, right? It doesn't matter what we input here. If it's not the number, it will be changed to NaN. So how many equivalent class I'm talking about now? I'm talking about two type of input. If we input the number, we will get a number. If we input something else, we will get nothing, and that input will change to NaN. Okay, this is example of how you think about equivalent classes. Okay, any question? Equivalent class is thinking about what should be the input. And it's if we input 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, is it provide the same type of the output or not? If it provide the same type of expected output and it's working as we expected, okay, we can think about 1 to 10 is the same equivalent class. It's one class, one type of input that we need to check, we need to test. And then if we want to input some kind of alphabet into that, and if we input that, we will get something else. And that is the second equivalent classes. This is an example. Okay, any question? Hello, anyone here? No? Question, thanks. So this is the idea of equivalent class. Since we don't have so that we have a limited time, we should provide the most effective data for test. And the idea is that we should be able to identify what should be the equivalent class of data for testing. Okay, this is my question. For this example, if you have int for this program, int x, if x is larger than 0 and x is smaller than, is less than 5, return y equal to 1. Else, return y equal to 0. And in the highlight, we expected result 1. There are two output type, which is 1. I should say 0 and 1. Okay. But the code here is like giving 1 out first. But anyway, how many equivalent class that we have? We have two input, right? Sorry, we have two output. At least we should have two equivalent class. So it means that the input that provide output as 1 and the input that provide the output as 0. So this will be first, mainly we can think about two equivalent class. So we can, if we have int x, so from this code to get 1 as the output, we have the range of available x will be 1, 2, 3, 4. And if if x is the other number, we will get output as 0. Okay. So if we test from -infinity to -1 and 0, and then 5, 6, 7, 8, this will given the output to be 0. So this is simple idea of identify the equivalent class. So how many equivalent class here? 2 or 3. Two or three. Hello, anyone here? Is 2 equivalent class for this example or 3 equivalent class? Two, just if you think if you take it as 2, because we have this 1 to 4 as one classes, and minus infinity until 0 and 5, 6 until infinity is the other equivalent class. But that is, if you think about it as 2, it's okay. Or if some people dare to be more detailed, they may think about separating this one to be like something like this. It's depend on what the document, the specification is right. But both of these are correct. You can think of it as 2 or 3 is okay. But but if the requirement said that the int must be larger than 0, so this part will be getting out. You have just like 5, 6 until infinity. So and then we have 2 equivalent class here. And the other equivalent class is that if we input something which is less than -1, what is going to happen if there are nothing set? Okay, sometimes we don't need to test it. But this is the example of how the equivalent class is used. Okay, this will be the example for equivalent class. I'll give you some time to just like 5 minutes to work on. Okay, the triangle program accepts 3 integers, which are A, B, and C as an input. The output of the program is the type of triangle. ABC must satisfy the following condition. You can use integer or double. A, B, and C is between 1 to 200. And A must be less than B plus C, or B must be less than A plus C, or C must be less than A plus B. This is second condition. From these two conditions, there are two equivalent classes, which is input, which those pass the condition, which means the ABC can generate a triangle, and the input that does pass the condition, which means ABC cannot generate a triangle. So question is, how many input should be tested, and how many input should be tested for two of this? The first, we should test whether if the input value is in the first condition or not. And if the value is in the first condition, whether it's passed second condition or not. So what should be the number of equivalent class that we should provide? So the first one is this in detail. If we have the value of A, B, and C between 1 and 200, so we have to input, we have to input A from 1 to 200. And if we have to input 1 from 1 to 200, about B, if you have to input A and B and C for all the value, it should be 8 million input, right? For the first condition. How many equivalent? What should be the proper input that should be tested here? Do we need to input estimated 8 million input to make sure that the program is working? Maybe not, because we can think that, okay, if we try to input something which is a number between this one and this one and this one, we have 3 equivalent classes to be proper input for A, proper input for B, and proper input for C. And then the other number, if that we need to test, is that something that out of this range, if we input something out of this range, what is going to happen? Okay, so we have about what? About A is, if A is okay, B okay, and C okay. If A is not okay, B okay, and C okay, what happened? If A okay, B not okay, and C not okay, what happened? Something like this. You need to test that. Okay, and then what? After we pass the first condition, what next? Okay, we need to check about this. If this is not matched, what should we do? If this is not matched, what should we do? If this is not matched, what should we do? So how many tests should we have? This is the question. So first of all, output of the program is the type of triangle. Actually, there are 7 or 8 type of triangle based on interpretation, but okay, this is a list of the type of triangle. So what are the equivalent class of the test? We have 7 input. We have 7 output as an answer of the type of triangle. We have 3 input and 7 output. Execute this condition, these 2 conditions. So, question: what are the equivalent class of the test that we should perform on this triangle program? Okay. And you can you help me? What should be the how should we create the equivalent class for this testing? We have 7 output. We have 3 input with this condition. No. Okay. Let's see. This is what are the equivalent class of the test. Consider an equivalent class. We just consider a set of input. For each input, it can share the classes. Only one representative of each class can be selected. If one representative can express many classes, so we need to separate the input. That is a way of thinking. For this example, for the equivalent class, just like this is an example, if we have the input range of x1 as b and input range of this so if you input this, we can input this one, and this one, which it will represent all the possible execution area of the variable. Okay, and this is an example of weak normal equivalent class testing. The word weak means single fault assumption. This type of testing is to accomplish by using one variable from each equivalent class in the test case. So for our test case, we have A, B, and C a triangle, and if you have put the proper A, proper B, proper C, and this is okay. That's the idea of weak equivalent. Okay, and then the weak normal equivalent class idea is a define equivalent class on the domain or range of input and output. Each variable for each variable, and the cover equivalent class for the domain for each variable, we have single fault of assumption. Just like if we have A, B, and C, which is proper and is provide the two output, the two output is okay. We can test only this one, 3 of this. So how many test cases are needed? We can need just input 3 of this and it's work. It's okay, but that is not proper because we have to test on if we input this and this. Just the idea. If you have the range of this, A is from 1 to 200, B from 1 to 200. If you need to define equivalent class of A and B, so what should we have? We should have from any number from 1 to 200 is in this box of B, and any number from this one, we can input any number of this. This is okay. And if this is for like this. We have A from 1 to 200. It's just fine. We can choose. We can use just one. And you have B from 1 to 200. It's okay for use just one. Corresponding to the first condition. Okay, but if we consider the second condition, it means that okay, A and B now is not enough. We have to consider C and blah 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 blah. The idea is that okay, we should consider if we choose this one, A is something between 1 and 10, and B is something between 1 and 10, and we how do we choose C? C should be less than A plus B. So the number of C should be less than something like this. That is a way of thinking about equivalent class input. But any one item that represents the proper execution of all the input is okay for equivalent class. Is weak normal? This is the question. What should be the minimum number that's put into this area to get proper coverage of test, and what should be the maximum number of this? And then, sorry, this is the whole slide. This you have to work on this. What are the test case for triangle problem for weak normal equivalent class? What is it? The idea is that we put this example, we have just two input A and B. Okay, but if we have A and B and C corresponding to this triangle problem, what should be equivalent classes? And then we have strong normal. Strong normal is that we have from the projection of A, we need to test three type of proper input. Projection of B, we need to, if B has two conditions, we have to input the proper type of input for B. But also if we have something like this, what should we do? We should select the value that is proper for all. Sorry, if we don't have this is okay. We test every possible of this, but if we have the other condition on the input, like A, B, and C, we should test every possible every possible input in every box. This is an idea of strong normal equivalent classes. And this is one more example. We need to combine every possible input that cover the area. And this is also the same thing. I will assign you the quiz. And we have some kind of weak robust. The weak robust is like we test the proper input and we try to find what is if we input something which is not in the range, expected range. This is to find out the to test overall the area, the possible area. And also we have to weak like this. We have the weak and we have strong, robust equivalent class. So it means that we try to identify every possible equivalent class here, and we test every possible of this, every possibility input that we get, that should be the proper input into our testing domain. And is some detailed explanation. Number of test cases should be something like this. And you have to you have 4 quiz, which is you have to deliver on the 29th of February. And in a while, if you have question, you can ask me. So the idea is that start from what should be the proper idea of input in the black box testing or any kind of testing. So we starting from we try to create equivalent class or the data that represent the range of the possible, or we create the input which can be represent as a range, proper range of input that we can get one expected output. And then if we have 2 input, we will have 2 range of the input that we may get 1 or 2 or 3 or 4 or 5 or any number of the output. Okay, and that is the idea of thinking about equivalent classes. And from this condition A, B, and C as triangle problem, if we think about weak equivalent, we may think about we input A between 1 to 200 is okay, and B between 1 to 200 is okay, but it is just only okay for the first condition. But if you check at the second condition, this kind of input we need to identify more proper equivalent classes for this. Okay. And the idea of using equivalent class testing, you can test just for weak normal equivalent, just provide the proper equivalent class for input and output, that is fine. But for weak normal idea is here, and we have strong normal equivalent class. Strong normal equivalent class is like we need more. We need every possible input in every possible range for every possible equivalent classes, and we test it. For strong and weak normal, we just test we just test in the range, in the proper specified range. But in strong equivalent, sorry, in weak robust and strong robust, we will need to test everything inside and outside of selected range. So there will be 4 types of equivalent class testing: weak normal, weak robust, strong normal, strong robust. And this is a projection idea of what should be tested. So you identify one equivalent class. How many equivalent class here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 times 4 is 20 equivalent class that you need to input for this projection. So get back to our question. From this, how many equivalent class? For weak we must for weak normal, we have 1, 2, 3 input, right? But from this condition, we have 3 equivalent classes. But further than that is your question: what should be the number of equivalent class corresponding to this condition? Actually, the answer is here 2 equivalent class. The class that passed this condition and the class which not passed this condition, and how you arrange, how you find out what should be the design of the input. And then for the example of this function, the other example for software testing idea. This is the definition of the next date function. The next date function receives the date, month, and year, and then return the next date string, which consists of the given format dd, mm, y, where dd is the number of date, mm is number of month, and y is a 4-digit number of year. However, we have the leap year, or the year which is divisible by 4, unless the century year are leap year only if they are multiplied of 400. So, and in the leap year, the leap year contains the 79 days in February. Okay. What is equivalent class for this function? What should it be? And what are the weak normal equivalent class for the test case? So strong, robust, and weak normal. What should be this from this function? Do you have any idea? So we have the output will be the date string. But when we input this string, this date, month, and year, the function need to consider whether this is a leap year or not. Right? And if it's a leap year, if the input is 28th of February, the next date must be 29th of February. But if the other kind of input, it can be any date that if you input the normal day, we will get the next date, whether it's leap year or not leap year. So we have to get the input, check the year, and return the date. And then what? That's it. We have two type of equivalent class. The input for normal year and the input for leap year. And then if the input is a leap year and if it's a 28th of February, we return. Next step will be returned 29th of February. And if the input date is 29th of February, the next date will be the 1st of March. But if not the leap year, if you return for 28th of February, it will return the 1st of March. That is, there are 4 of, how many of it? How many of it? We should test for the normal year and leap year. That's it. Okay, but you have to write down by yourself. You need to rethink again. And the next thing is that in the test, we're talking about the class. We think about the one value up or as a class, just like the class of A from 1 to 200, it will be any value, it's okay. But then the other thing that we need to concern is that we have to define the proper boundary value. We should do a boundary value analysis because error normally occur at the boundary. We should test a valid case, use any valid input as a representative. We find out the suspected valid case, the input which is in the boundary, An invalid case is inputted here, which is outside of the boundary. What does this mean? This means that if there's something so clear like this, which value for this value is outside of the boundary, and this value is inside the boundary, that is okay. We need to be sure that that is something that inside or outside of the boundary of our data for testing. And if we need to do analyze, if it's outside, it's okay. If it's inside, it's okay. And we need to further analyze what if it is at the boundary, what should be the output of this value. Just like, for example, triangle problem. What is the boundary value of A? It should be at 1, right? If A is an integer, 1 is okay. What is the next one? If the value is 0, this is okay. No. How about 0.99 if we input? What should be the output? That is the thing that we need to concern whenever we talk about the boundary value, because normally when we have a condition like this in our program, A is equal or larger than 1. So if A is 0.999, whether what is it at the boundary or not. And if A is equal to 1, it's okay. So at the boundary, and it's okay for this one. But if we have something like A is larger than 1, for integer, it's okay. For A must be 2 or 3 or 4, right? But if it's a double, can A be how about this? That is the thing when we try to design the input value, it got related to the boundary of the test. And sometimes people always think about this boundary value problem. But when you design a test, sometimes it's better to test at the boundary value of this. And also, this is also the proper test for the boundary value. Just at every edge, every cross section of the value, that is fine. And the robotics worst case testing is that we test every possible inside and outside of every possible things, every possible boundary value. That is the idea of testing. But the conclusion is simple, but you need to consider in a lot of detail based on the specification of the software or the function or the program. The proper way of testing is that you identify the input, identify the output, and identify which range of input should represent one class of the output. If you have one input and two output, it means that you may have two equivalent classes. If you have one input, three output, you may have three equivalent classes as an example. Or you can have four, just like one input for three possible output and the other type of output as an error or unexpected things. There may be four type of testing into this. Okay, this is an example for one input and two output. If you have two input and 8 output, how many equivalent class you should provide? It's based on whether you want to use week. What is it? 4 of that. Weak normal, strong normal, weak robust, strong robust test. Okay. The idea is simple, but when this is a simple theory, but the implementation when we design a test, it's not that. So that is for today. I will assign this problem. And this is a your homework. You need to work more, find more example until you understand what should be the proper number of equivalent class for this example as your homework. Okay? Any question now?
No, probably will have to go back and like review it a bit.
Any question?
Not yet, currently.
I
would like to review it first, though.
Sorry. I just I don't have the output, the sound output. Can you repeat your question again?
Oh, I will have to we probably have to review it again, like ourselves first.
Yes.
To be able to understand it. So no question yet.
Okay, thanks. As I propose, I want you to work because actually the test sometimes is not totally false or totally perfect, but you need time to think about the problem. And I just want this class to be participate and we discuss because regarding to this example, this one, I want to use this example because some people may have the answer of, okay, this is 2 equivalent class. I said it's okay. It's based on how you explain what is your idea of what test. Or some people may say that this should be 3. Okay, I accept it. And I think if you can explain why you want to choose this kind of 3 equivalent class, it's okay. Okay. Because the fact is that we cannot provide the proper number of testing because actually it's an infinite test, infinite data, infinite things. But to reduce the time, to make it efficiency, we should be able to select the proper input and output for our test. That should be, it depends on how effective your data is selected and whether it's cover the proper amount of range for test or not. That is the idea. And I need you to start working on this and we can discuss it. Okay. Any more questions? Okay. If not, the class will be again on Friday, and I will give the exact schedule again. Since I have the important meeting tomorrow, and I don't know how long it will take for. It's also on Friday. Anyway, I will give you I will update the schedule and let you know. And I expected to see you on Friday. Okay. Have a good day and bye. I will upload this slide.
Okay, thank you.
Okay, and if you have questions related to the quiz or homework, you can ask me to the chat or to the group post or the chat in the MS team. I will try to answer as soon as I can. Okay. Thanks for joining the class. There have been so many students now. And okay, see you again on Friday. Okay, bye.